Welcome to Activity 6.2, Can a Store Model Explain the Data? So this is a flip lesson, so a lot of the directions for 6.2 won't be relevant because you're doing this on your own, either because I'm absent and you have a substitute and you're in Google Classroom and you're doing it, or maybe you're absent and you're trying to make up this lab. Now the learning target for today is we're going to use the class storm model to explain the data from an actual storm. And I'll show you that storm model. I'll remind you where to find it in a few seconds. But the expectation for you is that you will complete the data analysis to help your team finish Activity 6.2. So the last time you did a flip lesson, some of you chose not to do the lesson and just to chat the entire hour. And for those of you who are in my 4th hour class, you know who you are. So make sure you're working hard. The expectation is that you're done with this before you leave today. So if you see other people around you not working, just, let them know. Hey, make sure you're working. So that way everybody stays on track. Now, first of all, let's look at this data. If you remember, this is the data we found from Activity 6.1. And in 6.1, you were looking at a data table. Well, it was actually a graph for temperature, air pressure, and humidity, and there was a data table for precipitation. And if you want to review this information, you'll see what we learned from those graphs and that data table. Now, it said we were going to use a storm model. Remember, this is the storm model that we had. Now, this storm model might look slightly different than the one I presented to you in class. I cleaned it up a little bit. I took a few things off there so it wasn't quite so cluttered. And this is what you had to know for the test. So, a couple things before we get started. Let me quick look here. Let me get rid of this shade down here. Now, when we look at what we did in 6.1 and when we look at our model, are each of the conditions on this chart accounted for in the model? And if you look at temperature, yeah, temperature is accounted for. We know that it's going to be warmer here, cooler here. How about air pressure? Well, we know that we have a low here. We have a high here, so you're going to have lower air pressure, higher air pressure. Now keep in mind, our model is very simplistic. It shows things moving from left to right, where weather does not always move that perfectly. Does our model show humidity? Well, it does. If there's precipitation here, or if the warm air is rising and being lifted up with this front moving through, we're going to have rain here. So it could show humidity. And precipitation, absolutely. You're going to have precipitation along this front. You could have precipitation here from these clouds. So our model does show us everything on this chart. But does it show us everything? Well, it doesn't show us wind. We could have had a data table that showed the wind directions. How about energy transfers, energy conversions, lift, instability, evaporation, condensation? These are all things that our model did not show us. I guess that's what I want to say. Now, condensation, it kind of did, which shows, well, if you have more humidity, more precipitation, obviously you're going to have condensation to make the clouds in order for there to be precipitation. Now, how is the model different from the data you looked at? So how are these things different? Well, our model is descriptive and qualitative, while the data is simply quantitative. So if we look at this, we're kind of drawing it in, saying this is what could happen. You could have a high, you could have a low. If that was the case, wind would go from the high to the low because the warm air is rising. This will take its place. That's not always going to be the case. Where this data is simply while a model is descriptive and qualitative, well, the data is quantitative. So we're looking at this and it's just, this is what it is. We're not making guesses. We're not trying to predict what will happen. This is what the graph tells us. This is what the data tells us. We're in this model, this is what could happen. And it's just that. It's just a model that could show us how things could change, where this shows us what actually happened during a storm. So how can you use the model to explain the data? Well, in the past, or in 6.1, we used this to try and explain what was happening. Now we're going to see if our models can help us explain it. So basically, all these directions, all these procedures that you see aren't relevant. It's going to tell you that I'm going to assign you a group and one set of data, and you're going to jigsaw everything. Well, because this is a flip lesson, you're going to be doing it by yourself. However, If you are doing this in class, feel free to turn to your neighbor or feel free to turn to your group and ask them, what did you get for this? What do you think the answer for this is? And well, I'll go through some of it a little bit later on, but the big thing is I want you to develop your own ideas, your own thinking. And I don't want to just tell you, oh, this is what your model tells you, because all of our models might be slightly different. And here where it says your group now needs to write an explanation, you will need to do that at the end of this activity. There is a spot for you to use your model to explain the storm. So do the best you can with that. And in number 3, it does say be sure to explain what is happening to the matter and energy before, during, and after the storm. So when we take a look at the first thing you have to do and you have to write, it says, what can our model explain about the data? So look at this data. And you might have to flip back and forth to the model. And again, remember, here's the model. So when we flip back and forth between the two of them, when you look at your model and you look at this, what can our model explain about the data? Is there anything that the model cannot explain about the data? So go ahead and see what you can do for that. Go ahead, pause the video right now. Okay, so you've had a little bit of time. So I'm not going to go through each of these with you, but I will go through this one with you to make sure you're on the right path. So what can our model explain about the data? Well, look at it. We see that the temperature is staying pretty steady. It's falling a little bit, and then all of a sudden it goes down sharply between 151 and 251. So in an hour, it drops about, what, 10 degrees, 8, well, not quite, about 8 degrees. And then it stays fairly steady. So could our model explain that data? Well, could we have the warmer air, could a front have moved through, and over the course of an hour, we went from the warm air to the cooler air? Again, it doesn't have to be cold. When we talk about a cold front still might be 95 degrees, but it might be cooler than what it was. So when we look at this question, can our model explain the data? Absolutely. So what can our model explain about the data? You might have wrote, our model could explain the data. It could have shown that a cold front moved through and the temperature dropped 8 degrees. Now, is there anything that the model cannot explain about the data? Well, what did you write? Yeah, and I guess I don't have one solid answer for that, or an answer that you're looking for, but what do you think? Is there anything that the model cannot explain about the data? So what I want you to do is I want you to go ahead and do the barometric pressure one. What can our model explain about the data? Is there anything that the model cannot explain about the data? So pause the video and answer this question. Okay, so you've had a chance. So I'm not going to go through and I'm not going to give you all the answer to these because I don't want you necessarily just to continue to play the video and then just jot down what I write down. So when we go over this in class the next time or at a future time, we'll see what you wrote for that. So go on to the next one. What can our model explain about the data? So here's the humidity. Is there anything that the model cannot explain about the data? Go ahead, pause the video and answer these questions. Okay, so you've had a chance to do the temperature, the barometric pressure, and humidity. Again, I'm not going to tell you the answers. I want you to write down something. I don't want you just to keep playing the video and just jot down what I say the answer is. But you can talk this over with your group. Talk it over with your neighbor. Talk it over with your elbow partner. Do you guys agree? Are you seeing the same thing? And then finally, what can our model explain about this data? So here's a data table of the rain. And is there anything that the model cannot explain about the data? So what can our model explain about the data? And is there anything that the model cannot explain? So go ahead and pause the video. All right, so you've had a chance to answer each of these questions. Now, the last thing you need to do for this activity is using everything that you came up with. Write an explanation to answer the question, why did the storm happen? Be sure to support your use of your model or of the model with the data. So now we're not only using the data, we're pulling in a model as well. So 6.1, we looked at just data. Back in activity 4, we used a model. Now we're going to bring them together. Write an explanation to answer the question, why did the storm happen? Be sure to support your use of the model with the data. Remember, you need to explain what happens to the matter and the energy. If you go back and read number 3, it says, be sure to explain what is happening to the matter and energy before, during, and after the storm. So go ahead, pause the video and answer that. Okay, now that you've had a chance to answer that, one last thing, turn to the scientific principles portion of your book, and here's a scientific principle I'd like you to add. Number 9, movement of air masses causes changes in weather in predictable ways. And this makes sense. This is how meteorologists are able to predict the weather. This is how, when you watch the weather, they can tell you what's going to happen in 3, 4, 5 days because they have models. Now, not models drawn on paper, but they have mathematical models. They have computer simulations. They have all these things that will help them develop an idea of what the weather is going to be like based on what it is now. So again, scientific principle number 9, the movement of air masses causes changes in weather in predictable ways. Thank you. Again, if you have any questions, please feel free to ask me in class.